Today we're going to talk about some of the problem-solving strategies that kids use in the Math Expression series in 3rd grade. One of the ones that they have already learned and should be familiar with is Math Mountains. In younger grades they were as simple as 2 plus 3 equals 5. We've called these things by different names. Instead of partner, we can call them addend, and instead of total, we can call them sum, but we still use partner total quite a bit. It's really important that kids understand that when you add those two partners together, you're going to get the total. And it's just as important that kids understand that whenever you start with the total, you take away one partner, you're always going to get the other partner. These are going to be crucial to understand as we move forward to getting our solutions. So if you use this strategy in this problem here, Stacy invited 9 girls and some boys to her party. We don't know how many boys, but we do know that 16 kids were invited in all. So I'm going to put 16. I'm also going to label my Math Mountain here as I go. I'm going to put 16 on top because it says that's how many there were in all. I'm going to put 9 and I'm going to put girls underneath so that I know those are my girls. What I don't know is the boys. I'm going to indicate that with a box. Again, I'm going to label that so I can keep track. Okay? Now there's a couple ways I can get at my solution. I know that partner plus partner equals total, so I know that 9 plus something equals 16. But I also know that if I take my total and subtract one of my partners, like the one I know, for instance, then that'll give me the other one. It doesn't really matter how I do it. When these numbers are small like this, it doesn't really matter. Either way will work. Okay? So some kids will say, let's see, 9 plus something, I don't know, I think it's 7. Right? So 7 boys, that is our answer. And because I've labeled it, it's easy for me to figure out that that's the answer. Kids also need to know that there's different ways they can write these equations. If they switch the partners, they're still going to get the total. And the same is true when they are subtracting. If they start with the total, it doesn't matter which partner they use next. They're always going to get the other partner. Something else I need to realize is that it doesn't have to go in this order. The sum does not have to go at the end. They can also start with the total at the beginning. 16 equals 7 plus 9. That's still an equation because both sides of the equal side are balanced. Just like they can start with one of the partners if they want to do a subtraction problem like that. 9 is equal to 16 minus 7. That still is a true equation.